Go.
So we're going to start learning how to factor binomials or polynomials. And the first thing you should know to factor binomials is that you should think of factoring binomials as working distributive properties backwards. The first thing that you need to do when you factor binomials is to find the GCF of all your terms. And one important thing to know is that the GCF of your terms could be a variable, or it could be a number, or it could be a combination of both. It could also be an expression like a plus 5 as your GCF. The second thing you need to remember when you factor binomials is that your GCF, once you factor out your GCF, once you determine what is the greatest common factor of all the terms, then that number goes in front of your parentheses and serves as your coefficient, or the number that you will distribute. A good thing to remember is that the quotient of the terms, once you find your GCF, you have to divide that GCF, all your terms, by that GCF. So once you figure out what number all the terms have in common, then you're going to divide all the terms by that number to get your quotients that are going to be left in the parentheses. So one thing to note about this step, and I'm going to tie it all together with some examples, but one thing important to note is that the quotient of the terms will be placed inside the parentheses. So after you find your GCF and you divide each term by your GCF, the answers that you get when you divide the terms by the GCFs are left in the parentheses. And step 3 is just to write your final answer, putting your GCF in front of the parentheses and the quotients of the terms inside the parentheses. So now we're going to go to some examples of what I mean when I say that. And you should have a paper with these 4 problems on it. They're not consecutive, but they're somewhere on the page. So example 1 on your paper, I think this is actually the very first problem on your page, says 6a minus 3b, and you have to factor that binomial. Well, the first step was to find the GCF. The GCF of 6 and 3 is 2, and since both of them have different variables, you can't pull out a common variable because there is not one. So the only thing that you can pull out is the GCF of 6 and 3, which is 3. Okay? So after you pull out that GCF, you need to divide each one of those terms, and this is a binomial, so you will have 2 terms. You need to divide each one of those terms by your GCF. 6a divided by 3 leaves you with 2a, and negative 3b divided by 3 leaves you with negative b. To write that answer as a final answer, you need to put your GCF in front of the parentheses, because that is the number you will distribute, and leave the quotient of the remaining terms inside the parentheses. So I have put in this all together. 3 is my GCF. When I divided 6a by 3, I got 2a. And when I divided negative 3b by 3, I got negative b. So I put that all in parentheses. And my final answer is 3 times 2a minus b. Okay? Example number 2, 4 minus 8a. The first thing I do is determine what my GCF is. What number does 4 and 8 have in common? Well, the GCF, the greatest common factor of 4 and 8, is 4. This has no variable. It's a constant. This has a. So there's no common variable for these 2 terms. So the only thing that you can factor out is a 4. So my GCF is 4. I'm going to divide both terms in my binomial by 4. 4 divided by 4 is 1. Negative 8a, because I got to carry the sign with this term. Negative 8a divided by 4 equals negative 2a. If I write my final answer, I'm going to put my GCF out in front of the parentheses and the quotients inside the parentheses. So I'm going to have 4 times 1 minus 2a inside the parentheses, and that's my final answer. Okay? Example number 3. Now I have a binomial that has variables in both terms, and there is a common variable. So the first thing I'm going to determine is what is my GCF. Well, this has a 5y, this has a y minus z. The GCF of 5 and 1 is 1. If the GCF is 1, I don't pull out a 1. I just don't pull out anything, or I know it's 1 in my head. Sometimes you can write the 1, but you don't have to write the 1. So then I go to my variables and see if they have a common variable. If there's a common variable, in each term. And there is. Each term has a y. So I'm going to suck out that y. I'm going to pull out that y as my GCF. So my GCF is, and there's an understood 1 in here that you don't have to write, but you can if you want. So I'll put it just so you know. My GCF, because my GCF of 5 and 1 is 1. And then the GCF of 5y and yz, what's in common is a y. So I pulled out a 1y. And now I'm going to have to divide each term by my GCF. So 5y divided by y leaves me with 5. And negative yz divided by y leaves me with negative z. That's not a 2, that's a z. Okay? And so to write this all as a final answer, I take my GCF, which is y, put it out in front of the parentheses. And inside the parentheses are the terms, the quotients for the terms that I got when I divided by my GCF, which is 5y minus z. One final example is 6m minus 2lm. I now have to pull out my greatest common factor. Well, if you look at the numbers, 6 and 2, they do have a greatest common factor of 2. And then if you look at the variables, both terms have an m. So I can pull out a 2m. My GCF is going to be 2m. Now I take that GCF and I divide each term by that GCF. 6m divided by 2m equals 3. Negative 2lm divided by 2m equals negative L. That's not a 1, that's an L. That's AL. So to put this all together, I put my GCF out in front of the parentheses as a coefficient, and I have 2m in parentheses times 3 minus L. And that's how you factor binomials. Now on your paper, you have some more to practice. So practice factoring those binomials and make sure you bring this paper back to school on Monday, April 7th. Have a happy spring break.